Okay, so in this video we're going to be graphing quadratic inequalities in one variable. So 0 is less than x squared minus 6x plus 5. So you may have watched another variable we were graphing them on the coordinate plane, but those inequalities had an x and a y in them. This inequality only has an x in it. There is no y. So rather than graphing it on a coordinate plane, I'm going to graph this inequality on a number line. Okay? And actually, I'm going to make my number line first, and then I'm going to write my solution set. So what I'm going to do is I'm going to start by saying, okay, let's suppose this is 0 equals. Because really, I don't know how to solve a problem that's less than. But I know how to solve a problem that's equal. With two x's, quadratic formula, or factoring, I'm going to go with factoring all the time, as much as I can, because it's just so much easier to factor. And I'm going to get solutions of positive 5 and positive 1. Okay? And if this were an equation, I would be done. But now I've got to go back up here and revisit and say, oh, it's less than. So over on my number line, I'm going to go to 1, and I'm going to put an open circle. I'm going to go to 5, I'm going to put another open circle. And why did I use an open circle? It's the same idea that we've discussed all year. It's a less than sign with no equal to underneath it. Without an equal to, I've got to keep my circles open. Okay? Now, with inequalities, we've always shaded. And if I look at this number line, there are three areas that I could shade. I could shade to the left of 1, I could shade between 1 and 5, or I could shade to the right of 5, because that does go on to the right. I've got to determine where to shade. So, in order to determine where to shade, I'm going to use test points. I'm going to choose one point from each area. So, for example, 0 works for left. 0 is less than 0 squared minus 6 times 0 plus 5. 0 is less than 5. That is true. So I know that I can shade over here. Okay? Let's check the number 2. 0 is less than 2 squared minus 6 times 2 plus 5. 0 is less than 4 minus 12 plus 5. 0 is less than negative 3. That's not true. So I'm not shading here. Let's try 6 for that last area. Okay. 0 is less than 6 squared minus 6 times 6 plus 5. 0 is less than 36 minus 36 plus 5. 0 is less than 5. That is true. So I'm shading over there. So that's actually the graph of my solution. My solution itself would be written as x is less than 1 or x is greater than 5, because these two shadings are going in opposite directions. Alright, try that again. We'll go 2x squared minus 5x plus 2 is greater than or equal to 0 this time. Okay, again I'm going to factor it, so 2x, going to use Billy's method here. Okay, I used a little bit of guessing and checking and happened to get it correct that way, but you could use Billy's method and you should get the same thing that I get. Remember that we're going to make it equal 0. So now I have to remember 2x minus 1 equals 0, x is 1/2, or x is 2. Going to go to my number line. Okay, 0 on my number line, 1/2, close circle, because it's or equal to, and 2, close circle. Okay, I have three areas that I could check. Let's check the 0 first. 2 times 0 squared minus 5 times 0 plus 2 is greater than or equal to 0. 2 is greater than or equal to 0. That is true. So I'm going to shade outside here. Let's check 1. So 2 times 1 squared minus 5 times 1 plus 2 is greater than or equal to 0. 2 minus 5 plus 2. Negative 1 is not greater than or equal to 0, so I cannot shade there. And let's try 3. So 2 times 3 squared minus 5 times 3 plus 2. 18 minus 15 plus 2. So that's 5, which is greater than or equal to 0, so I can shade there. So this is another example where after I make my graph, I know it's going to be x is less than or equal to 1/2, or x is greater than or equal to 2. By the way, if I were shading in between them, then I could write the expression 1/2 is less than or equal to x is less than or equal to 2 as my solution. But because I'm shading outside, it is an OR compound inequality.